cubic congruence. Now towards that we need to solve the regular cubic equation, and so possible zeros would be the divisors of 6 over the divisors of the leading coefficient, and some of those are 1 over 7, 2 over 7, and 3 over 7. Now I stopped there because that one works. Now there's plenty of others. But these are some of the potential rational zeros, and 3 over 7 turns out to be a rational zero. I'll put the ellipsis right here. Y'all, this synthetic division that you see right here proves all of that, or does all that for you without having to do long division. Notice we just bring this 7 down. 3 over 7 times 7 produces this value 3. When you add, you get negative 7. Minus 7 times 3 over 7 gives you minus 3. Add, you get minus 14. In a similar fashion, you'll end up getting 0 right here. Now, what does that mean? That means that 3 over 7 is an actual root, and so that means it becomes a factor, which you can see right down here. Now, also, this row of numbers right here gives you the coefficients of the quadratic expression, and I just factored the 7 out, and you can see that right down here. Now, notice this factors very, very nicely for us, and so let's move on down here a little bit. Now, notice that what's going to happen right here, because of the factorization, if this were just if we were just solving the non-congruential version of this, the answers would be x equals to 3/7, x equals 2, and -1, okay? And we'd be done, right? But we're interested in what's going on with this thing, mod 19, okay? And so let me get up here where I belong. Okay, so that's 2 and then -1, okay? So the big question is, what is this 3 over 7 with respect to modular arithmetic? That's really the toughest part of the problem, I would think. And so what we can do right here is just think of it in these terms. Write x equals to 3 over 7 as 3 times 1/7. Okay, 3 times 1/7. All right. We're going to try to give meaning to this. What is 1/7? Well, we need to look at the following congruence for it to make any sense. We would have 1 over 7 times, we can write it in any order here, but we want this to be just like it would be with rational numbers. 7 times 1/7, okay? We want it to be congruent to 1. See, if you just think that as an equal sign, this is exactly what's going on with the rational numbers or the real numbers, but we're doing it now in modular arithmetic land. So we got mod 19 right here. Now, so folks, a way of thinking of this is just you're looking, 1/7 has to be a number such that when you multiply it against 7 and subtract 1, you get a multiple of 19. Now, so right underneath here, and I'll just write down the answer because it's it's a little tedious to do the process, but it's something that's achievable. 7 times 11 is congruent to 1. Okay, that's because this is 77 minus 77 is congruent to 1, and that's because 77 minus 1 equals to 4 times 19. Okay, so you see 1/7 is literally 1/7 is literally equal to 11. 1/7 is 11 modulo 19. And so right here we can write this as equals to 3 times 11 God, this makes me so Okay, 3 times 11. All right. But notice that this is, if you write it now, so that's equal to 33, right? So what we end up with right now is that x is congruent to 33. Which is congruent to 14 mod 19. Okay? And so that's normally what we're looking for, is the smallest positive value that's less than 19. I mean, 33 is an answer, but we look for the reduced congruent, or whatever they call it, the reduced residue, least positive residue. And so 14 was the hard part. In other words, 3 times 1/7 is equivalent to saying 14 modulo 19. And so our two solutions, we would have right here, as far as the overall answer goes, the answer to this congruence, it would be 14, 2. Now, notice that -1, right up here, this -1, it's an answer, but usually you do the least positive, like I just said a moment ago. So -1 is congruent to 18, right? Mod 19. Okay, -1 minus 18. -1 minus 18 is minus 19, and so of course this is mod 19. Okay. Okay, so what does that mean? The complete reduced least positive, I should learn the language, shouldn't I? This is the final answer right here, folks, and you can check these out if you want to. 2 is actually not too hard to check. The other numbers are kind of large. Okay, but for example, if you put 2 in here, I think you get 56 minus 40 is 16, and minus I believe it works out to 7. I'm not sure. But in any event, you can check all of these numbers in the original congruence and notice that you actually get multiples of 19 when you solve them. Okay, hope you enjoyed.